understanding how to maintain glucose homeostasis has two arms, if you will. There's what do you do when blood sugar is low and how do you fix that? And that's what this video is about. And then there's understanding what to do when blood sugar is high and how you remedy that. So big picture to think about is that with these two arms, there's generally two opposing hormones that we want to think about. Both are derived from your pancreas. And so when we're in a low blood sugar state, we need to think about the incorporation of glucagon. That's a low blood sugar hormone. And then when we are in a high blood sugar state, we have to think about the incorporation of insulin. Okay, so big picture, when you are under low blood sugar circumstances, there's two ways that you can remedy this. We're going to call it a top-down and a bottom-up approach. Top-down is taking your animal starch, if you will, which is what glycogen is, and breaking it down to glucose, which then can be used as needed. Another route, which we're not going to talk about the details of here, but I do want you to understand this name, is gluconeogenesis, or a bottom-up approach. That's making glucose from other non-carbohydrate sort of molecules and allowing us to remedy that low blood sugar level. Okay, so this is the low blood sugar arm, and we're going to talk about how glucagon, the pancreatic hormone that's responsible for signaling that you're in a low blood sugar state, can allow for the breakdown of your reserve of glucose as the polymer glycogen. Okay, so let's kind of just start annotating some pieces here. So what is glycogen? Again, glycogen is a sugar or carbohydrate that acts as an important energy store for your body. So if we think about sort of labeling what glycogen is, we're going to call it animal starch. And that's because it is a homopolymer of glucose that has alpha-1,4 glycosidic bonds with alpha-1,6 branch points. So let's write that down. This is a homopolymer of glucose. And important pieces is that there are alpha-1,4 glycosidic bonds, and there are alpha-1,6 branch points. So if we think about plant starch is also hooked together with alpha-1,4 glycosidic bonds. That alpha piece is a reminder that this is fuel. And then to have multiple branches, if you will, that creates multiple ends on this glucose homopolymer. And as we'll learn next semester, that's important for how we quickly mobilize this. So these alpha pieces are important. The branch points are going to be important for rapid mobilization, but that's what glycogen is. Now there's lots of words here that are easy to get confused. Glycogen is this homopolymer of glucose, this animal starch. Glucagon is the hormone that signals, hey, we want to break down this glycogen because we are under a low blood sugar level. Okay, so just a few other things to think about with regards to glycogen. You basically have a 12-hour supply of glycogen in your liver. So about a 12-hour supply in your liver. And as we'll talk about, it's not like as soon as you hit that 12-hour mark, all of a sudden it's gone. You'll have a gradual sort of changing and a slowing of its breakdown, but it's meant to be about a 12-hour supply of glycogen. At that point, if you are no longer able to have that top-down approach to remedy your low blood sugar, then we have that gluconeogenesis kind of ramp up to still maintain that important 5 millimolar glucose level that you need to have in your bloodstream. Okay, so let's talk about the two places in your body that you store glycogen, or the two main places we're going to focus here. We store glycogen in your liver, and about 5 to 6% of your weight of your liver is glycogen. So not an insignificant kind of component to your liver. And then muscle glycogen is about 1 to 2% by weight. So not as much, but these are two main tissues that have glycogen reserves. So let's talk about how these are broken down and where this glucose goes. So let's first start with your liver. So when we talk about your liver breaking down glycogen, when you break down glycogen, which is a homopolymer of glucose, you get glucose. Now, importantly, this glucose is released to the bloodstream, okay, by your liver, and thus it can serve a global use. So it can help with a global sort of shortage of blood sugar, okay? And let's contrast that to what we see with muscle glycogen. When we consider muscle glycogen, the breakdown pathway is going to be the same, and we'll learn about that breakdown pathway in Biochem 2. But when it is broken down to free glucose, that is only used locally. So we've got local use. And we'll learn next semester why that is. It has to do with enzymes that are missing and transporters that are present or not present. But basically, glycogen in liver is meant to help with a global sort of remedy of low blood sugar. And glycogen in muscle is meant to be used locally. Okay, so let's map now onto this, how we think about sort of this hormonal piece that's going to affect whether or not glycogen is broken down. Remember, glycogen being broken down is going to happen in a need state. So let's talk about the pancreas. Okay, so the pancreas is going to be an organ that synthesizes a lot of different hormones, but in this context, we're talking about the synthesis of glucagon. And I cannot spell today, glucagon. Okay, so glucagon is again a signal for low blood sugar. So it is going to produce when we've got low blood sugar. Okay, so that's going to be a signal for low blood sugar. Low blood sugar, pancreas secretes glucagon. Okay, now importantly, glucagon is going to interact with receptors that are on the liver, and that's going to be an external signal for the liver to break down glycogen to free glucose, release that glucose to the bloodstream, and help remedy that low blood sugar situation. Okay, so now let's talk about another sort of situation, adrenal glands. Okay, adrenal glands, those are glands that are on top of your kidneys, again, other part of your endocrine system. These are going to produce epinephrine. And this is a fight or flight hormone. So basically, if you find yourself in a situation where you need to have energy to either fight or run away, your adrenal glands are going to produce epinephrine. And importantly, I want you to know that this is a need state signal. And importantly, we can also map on that glucagon is a need state signal. So big picture, we've talked about this already. Need state signals are going to put us into that phosphosystem. And that means we are going to have a lot of kinase activity. Okay, lots of phosphorylating going on, decorating things with phosphates. Some processes it's going to upregulate, some other processes it will downregulate. Okay, but need state signals are going to be epinephrine and glucagon. Now, if we think about who responds to this epinephrine signal, not only does the liver respond to that signal because it's going to say, hey, you need to fight or flee, we're going to take some of our energy reserves, break them down to glucose, put it out to the bloodstream, because you know what? Everybody's going to need to have all hands on deck, and we're going to provide some energy to do that. And muscles also have receptors for epinephrine, because if you're going to need to fight or flee, they're going to want to know that information as well so that they can break down their glycogen reserves to glucose and then be able to use that locally for whatever needs to happen. Okay, so this is sort of this pathway for this need state. And we mentioned it in the beginning, but just to kind of put it down here, we need to maintain 5 millimolar glucose. And we can fix if we are not having that level of glucose, if we have fallen below 5 millimolar glucose, which in that case, we're going to have glucagon. I cannot spell here, glucagon. Glucagon is going to be secreted from the pancreas. So what's going to happen is we have two things. We can have this top-down approach. So we're going to call this a top-down approach. And we can take glycogen and break it down into free glucose. In the liver, we can circulate that out to the bloodstream and fix that low blood sugar situation. Alternatively, we can have what we're going to call a bottom-up approach. And this is going to be through a process called gluconeogenesis. We'll learn about the details of that next semester, but I do want you to know that word right now. Gluconeogenesis is going to take non-carbohydrate precursors, and it's going to convert them into glucose. Two ways that we can help remedy that low blood sugar situation.